Okay, let's dive right into this explainer and uncover the actual secret ingredients of mechanical power. We're going to break down the specific, invisible components that have to combine to create true mechanical energy, step by step. So, picture this. You've got a massive, heavy box. You plant your feet, you grit your teeth, and you push with literally everything you have. You're exhausted, but the box doesn't budge, not even a millimeter. In physics terms, did you actually generate any power? I mean, it kind of feels like you did, right? You're sweating. But the actual mechanics tell a very, very different story.
Part 1. Meet the dynamic duo.
First step in our duo is effort. This is exactly what it sounds like, the raw, physical push applied to an object. When you're shoving that stubborn box with all your might, you are supplying the effort. It's the brute force, the literal push in the whole equation. But here's the catch. Effort isn't the whole picture, not even close. We also have to introduce its partner, flow. Flow represents the actual movement or velocity happening in a given situation. So if effort is the physical push, flow is the resulting movement from point A to point B. All right, part 2, the heavy box challenge. Let's jump back to our stubborn box for a second. If you crank up your physical push to the absolute limit, like you are giving it 110%, but the box still doesn't budge an inch, do you have any flow? No, not at all. Because the box stayed completely stationary, your flow is exactly zero. You had all that intense physical exertion, sure, but without motion, flow is completely MIA from the equation. Okay, let's flip the scenario completely. Say that same box is suddenly sitting on ultra-smooth wheels. It zips right across the room, but you barely even had to touch it with your pinky finger. In this situation, where the movement is super easy, is your effort high? Nope, it's extremely low. I mean, you have plenty of movement, right? So you have plenty of flow, but the actual physical push is totally minimal. And this shows us that just as effort couldn't get the job done alone, flow also struggles to generate any actual real power by itself. Which brings us to part 3, the mechanics of power. This perfectly illustrates the contrast between these two extremes. With a stationary force, you're sitting there with high effort but absolutely zero flow. And with unresisted movement, you've got zero effort but incredibly high flow. But here's the real kicker. Neither of these isolated scenarios actually gives you power. So what actually defines power then? Well, it's remarkably simple. Power equals effort multiplied by flow. True power is literally the mathematical product of these two distinct forces working together. To generate any kind of significant output in mechanical energy, you fundamentally need both, the push and the movement. Moving on to part 4, the power of cooperation. Let's bring this all together and look at the matrix. High effort mixed with zero flow gets you nowhere. No power. Zero effort mixed with high flow does the exact same thing. No power. It is only when you combine high effort with high flow that you actually generate true power. These two components have to happen simultaneously. They are a package deal. So let's wrap up our core takeaways from this explainer. 1. True power absolutely requires simultaneous cooperation. 2. Effort acts as your physical push. 3. Flow acts as your resulting velocity. And 4. The golden rule of mechanical energy. Neither of these guys works in isolation. You have to have both to get the real deal. Now, I'm going to leave you with this to chew on. Take a look at the world around you today. Where do you see effort without flow in your own daily life? Like, where are you basically just pushing a stationary box, exerting all this physical effort, but seeing absolutely zero velocity in return? Spotting those imbalances in your own routine, that's the very first step to finally generating true power.